This lesson is working with comma-separated value text files, and this is the first of several short lectures that recap where we have gotten from the beginning of class to where we are now. So, working with programming for business, you need to have data that you can process with your program. And so I have an example here where I downloaded transactions from my Wells Fargo checking. I obfuscated the data for privacy reasons, but the format that you're going to see in this lesson is the actual format that you get from Wells Fargo. So I'll list the files in the current directory, and you notice that there's a Wells Fargo data.csv. Again, CSV stands for comma separated values. And real work gets done when your programs work on data. This file happens to contain data from a Wells Fargo checking account. Let me show you what it looks like. That's the whole file. And I can just clear the screen and show the first couple. There's the first two lines of the file. Now the fields, you'll notice, are separated by the comma character, hence the name CSV files. Each line of this file represents a distinct transaction, a debit or a credit against my balance in my checking account. Each transaction has 5 fields separated by 4 commas, and you can see the commas here. So the first field obviously is a date. The second field after this comma is the debit or the credit. The third field, we don't know what that is, so we'll skip it for now. The fourth field, we don't know what that is. That's an empty field. The fifth field here is the description of the transaction. So the double quotes around each of the field data is noise, and we have to deal with that. In fact, we don't even need it unless commas appear embedded in between those double quotes. And to figure that out, we actually have to analyze the file that we get from Wells Fargo to see what does this file look like. And so one way to do that is simply to run the less command. You can do this on Windows in the Ubuntu terminal or on Mac OS X. And we just start scanning down the columns, and I notice that there's a star in every record, and there's a blank double-quoted field after the star in every record. And I'm using the term record loosely. In a text file, a single line of text is the same as a record. And so if I hit the space bar and just kind of scroll down, I can't really tell what the star is or what the double quoted empty field is. Oh, until we get right here and you see this double quoted empty field has a check number in it, and the description says check number 7370. So occasionally I will write a paper check that I give to somebody that they deposit in their bank that transfers to my bank, and then the money for $100 gets taken out. I don't know who it's to. I'll have to go back to my check register or log in online to see if I can determine who the payee is and what is the purpose of this transaction. As I continue hitting the space bar, I continue scrolling down, and I get nothing but stars, and here's another check. So this is how you would analyze it. And you're looking for similarities, or you're looking for weirdness that you're going to need to deal with when you are writing a program to process this data. So I'll hit space. Okay, I'm at the end of the file, and it looks like pretty much every single transaction has a star in it. So I can ignore that. It doesn't add any information. And let me now show you what the contents of the printing and non-printing characters look like in this file. So we can see up here, field 1's a date, field 2's an amount. We have the star, Now we know this is the check number field, and this is the description, and then that's the end of the record. But how does our program know it's the end of the record? Well, if you look at this command here where I've dumped out the printable ASCII characters and the non-printing ASCII characters, you'll know they're non-printing because you'll see multiple characters. So that's a space. That's just a printable representation of a space, which you normally can't see. Here's another space right here. And you'll notice there's this NL, that stands for new line, and that is the end of the record. So under the covers, we have all of this data, and then after this last double quote, there's an invisible, non-printing new line character stored in the file. And this reveals it here using this OD command, but you don't need to know that. So now that means that the first character after the new line is the first character beginning the second record or the second transaction in this file. And sure enough, if I assume there's a new line here and then I go back to the next line, there's the double quote, and then we see a date, and then we see negative $40. So if we follow this around, here's the date, and here's the negative $40, and so on. So that's how we need to view this file when we're trying to process it. So programmers will look for the end of the record marker, which signals the end of a text line. So all Unix boxes, Linux boxes, OS X boxes generally terminate their text files using a single character called the new line or the line feed, which is an ASCII 10. But on Windows computers, text files are terminated with a 2-character sequence called carriage return line feed pair, which is an ASCII 13 and an ASCII 10. And so that creates a little bit of difficulty when transferring files between Windows and Unix, Linux, and Mac OS X boxes. But shouldn't bother you too much, and the C library routines kind of handle that transparently, depending on which routines you're using. Okay, so that's how we evaluate the file, and that's the end of this lesson. In the next lesson, I'm going to show you the basic C programming and C++ programming language structure.